Okay, let me stop my screen sharing for a while. On my stop my screen sharing. Okay, for the benefit of people who just log in, today we go slow and steady. Two reasons. Wait, three, sorry. People are having camps last week, so I want you guys to catch up a little bit with the feeling, right? But I noticed that some people are not comfortable upgrading their notes. I consider upgrading notes to be the most important thing when we are covering questions. You can only upgrade your notes while doing serious questions. Prelim questions are serious questions. If you do them and you don't upgrade your notes, even though you feel that you're learning something, even though you feel like, oh, this is a very interesting question, but you don't upgrade your notes, then you are very confident of your brain's ability to remember things. I have no doubt about that. The problem is that you have 8 subjects and you have a lot of topics in those subjects. Your brain must make space for other things. You will forget about them, not because you're a forgetful person, but because you're a busy person. You're busy with your subjects, you're busy with your CCA, you're busy with your friends. Those are very good and healthy. So let's upgrade our notes. And I want to just show you the simplest way of doing it so that you will do it, like, I suppose, right? So upgrading your notes. So we'll take it slow and steady. Whenever we introduce skills like this, we have to go slow. I cannot go fast in introducing new things. Hopefully that's something good luck for most people, right? Okay, so that's it. I'll share my screen first. Sorry. Nicholas, are you here, Nicholas?
Yes.
All right. Then to be fair, I should do a different school with that. Okay, I'll use an example to show you what it means to upgrade notes. Okay, one more time. Upgrading notes can only be done by doing serious questions. So here comes the serious questions. It's not that difficult, okay? Don't worry about it. Get ready your notes if you don't have it. Oh, we did that already. Really? Oh, we did. Okay, never mind. Let's go to Chochokang. This is not that difficult. This is not. Okay, let's try this one. Okay, very fun. Again, for the sake of everybody, I will repeat. MCQ gives you question in order of the topics learned. Organic chemistry is the last topic, so it's very easy to find them. It's usually at the back. Okay, so happen this one start at 34, some start at 35, some start at 36. Just the variation, right? Now, reaction map should be something you immediately hold on if you do not know what's going on. Reaction map is that powerful. Reaction map is, oh my goodness, sorry. Reaction map looks like this in your notes, right? Okay, so now, which of the following could not be produced when methane reacts with chlorine in the presence of ultraviolet light? First thing you do is to identify where the reaction is, right? Matthew, which one is this reaction? The position of the reaction.
Sorry, what?
This question might contain a reaction from the reaction map. If it does contain, which position? Where is it?
Oh, top right.
Right. And the arrow going out plus UV, blah, blah, blah. Okay. So if everybody identify this, that's not the upgrade of the node. Okay. That's already in your notes. Now, the question is, can you answer this or not? Okay. In every question which are serious, by right, you should be asking questions to clarify. So everybody read your question and then ask to clarify lah. If you already know the answer, just tell me also. Is the answer this? Sure. But most probably, you will be clarifying something here. I'm waiting for the clarification. Anu, do you have an answer or do you have a question?
I need more time to process this.
Please do. Joel, answer or question?
Still looking at 34.
Please do. The position of the reaction is definitely correct by Matthew. So that's not the confusing part. That is definitely not. Vera, answer or question?
Sorry, I'm still reading 35.
35? No, 34. 34.
Oh, at 34? Is it
Right.
D?
Your answer is D, and the answer is correct. Thank you. You can answer. You can go to 35. Now, since somebody already have the answer and the answer is correct, then time to explain. The thing is, you may not know what this name is. The thing is, you may not know lah. You may not know, but you know that methane looks like this with all the H's, and you know that this reaction is with Cl and Cl, and you know that this will swap with this guy. Now, this guy is swapped in total randomness, and you don't have this node in your reaction map, then please do so. So he will choose anything in random. Now, that means you will produce something with a Cl and something with a HCl. And that's why your HCl is correct, because remember, the Cl and the H swap position. You may not know what's tetra, but chloromethane simply indicates a chlorine replacing the supposed H. That's your chloromethane. Tetrachloromethane, whatever that means, tetra is 4. So he's saying that all the H has been replaced. This is entirely possible. Entirely possible. What is not possible is to produce hydrogen, of course. That is not possible at all in this reaction. If anybody is not clear, please tell me right now. So Anu, what is something new for you in this question? Remember, guys, we're discussing how to upgrade nodes, so I have to go a bit slow, right? Anu, is there anything new for you? Connection test. Matthew, can you hear me? Matthew?
Yeah.
Okay, all right. Anu, anything new for you? Yeah, now I can, but the mic is very bad. Can you try speaking again? Oh, it's very bad. It's very bad. Matthew, can you confirm that Anu's voice doesn't sound very clear?
Yes, it does not. It's not clear.
Yeah, it is definitely not clear, Anu, but Matthew's voice is clear lah. Right. Okay. Some other people first, yeah. Matthew lah, Matthew. Is there anything new for you?
I didn't know like all the hydrogen could be swapped out for chlorine.
So something to do with tetrachloromethane, correct?
Yeah.
That is supposed to be the new thing. I do notice that because I've never mentioned that before. Too much complication back then. But now people can understand. So what do you do? Now, I would like to suggest something very simple in upgrading your notes. Something that doesn't mess it up. Okay, what do I mean by that? If you keep adding things into your note, there is a chance that it becomes not clear anymore. Not clear is not good. Not clear is not nice. I'm sorry, where's the... There you go. Wait. Right. So let's say we know that the note should be around here. That makes some sense. But let's say you don't have a lot of space to write things and you feel that you need a lot of space. Well, GoodNote can help you with that. Okay. So why don't we just use for today, at least, I will ask you everybody to try using the post-it, which I choose a very bad color. Wait, sorry, I chose a very bad color. I think yellow is better, right? Now, to remind you, post-it can be made as small or as big as needed, and you can actually write things in the note. So the worst thing you can do is write something like that. Tetrachloromethane. Let's say you don't know how to write down, just write down tetrachloromethane. You see that? And then you write down what you learned. More than one H can be swapped for Cl. Okay, something like that. Okay, and then I will collapse it. Then I will I'm so sorry. I'll position it. Sorry, I'll position it here, and then sorry. Then I will just collapse it. Okay, that might help you to view next time, right? Now, if I move it here, you don't have to worry about not being able to see. You can still see it that way, right? Something like that. One more time. I suggest that everybody upgrade this using post-it because it'll take care of the space problem. It doesn't confuse you. Next time when you want to view it, it's actually quite easy. You can even have 10 post-its. It won't be confusing. Now, please do this. This is one of the idea today. I want you to effortlessly upgrade your notes. Now, when you're done, please thumbs up first. Vera, I know you're looking at 35, so please wait a bit for a while. Okay, again, I need to see some thumbs up for you finishing upgrading your note. Okay, thank you. If you want to write down slightly differently, there is no problem at all. In fact, you should probably practice doing that. Okay, Joel, Matthew, Sean, are you done with your upgrade?
Wait, what do you write at the bottom below the drawing?
Yeah, that's probably not something I should have done, right? Okay, I should have just do that. Okay. More than one H can be swapped for Cl. Sorry, yeah, a bit bad. My writing is always bad. Okay, Joel, Sean, is everything upgraded already? Okay, good. Now, let's continue doing that a few times until you feel very confident. Hey, every time I learn something new, I'm going to put something in my notes and it will not make me confused at all. In fact, I'll be very happily revising this next time. That's the hope. Let's go back. Okay, now I'll be deleting this. There will always be one isomer question. Sometimes it's very troublesome. I can assure you this one is not troublesome. It is not troublesome at all. Okay. Questions or answers? Okay. Vera, let's start with you. Vera, do you have any questions to clarify?
Is this reaction table also?
Okay. Will reaction table help you? Well, reaction map lah, yeah. So let's answer that. Okay. Ostensibly, this is isomer lah, but obviously there's a double bond and everything. And he also already say both will react. So clearly there's a reaction going on. Ask you back, Vera, this reaction with bromine, is it part of the map?
Yes.
Okay, and again, just to, yeah, there's one, okay? Is this guy, just to short things up, okay? Now,
Okay.
Vera, might as well answer lah. Both produce the same molecule when reacted with steam. Is this part of the reaction map?
No.
Check clearly, Vera and everybody else. Now, they made it easy. We have to start from this star part, right? This is the only way to start. That's the butane. However, Vera, you might not notice that reaction with steam plus H2O, correct? There. That reaction.
Oh.
Make sense or not? Okay.
Yes.
Third reaction, Vera, is it in the reaction map or not?
Yes.
And which one would that be?
Butane to butane.
Yeah, something like that over here. People, this is not an upgrade of your reaction map, but using it. Okay, it's always very powerful, right? And combustion, just finishing up, Vera, is it in the reaction map?
Yes.
Definitely here, there, plus O2, there's the combustion, there's plus 4. So, wow, this question is very greedy. This question kind of makes you think a lot of layers, right? Okay, not nice for exam, but very nice for learning purposes. Now, questions or answers lah. Vera, thank you for clarifying for us. Anu, let's test your mic again. Do you have any question or do you have some answers?
No.
All right. Not yet. No answers yet also?
No.
All right. Think about it again. Think about it. Joel, are you still reading or are you starting to do already?
Starting to do.
Okay, good. Okay, very troublesome question. You must evaluate one by one, but good for learning lah. Nicholas, are you okay? Do you have some answers?
I'm still thinking.
Good. Yeah, it's a very troublesome question. Very, very troublesome. Sean, anything to clarify?
Oh yeah, I'm kind of confused. Like I don't know how to start.
Right.
Like, yeah.
Now, people, this is prelim question. They just plonk every topic lah. Your reaction map is not wrong at all. If you think all this reaction exists in the reaction map, totally a very good use of the reaction map. Nothing wrong. But they kind of combine with, the mole chapter lah. I'll tell you straightforward, this is not even an isomer question. They just start that way. Reaction map, very easy. This is more like a mole chapter, and that requires a lot of consideration. Get ready to upgrade your notes. Now, let's talk about first reaction. In case you forget, the best thing in organic chemistry is to draw. Please draw. You don't even have to draw the H. Just leave it blank. When you leave it blank, you're communicating that there's a H there. It's a shortcut, you know. It's annoying to draw that.
Teacher.
Yes.
You wrote the last C wrong.
Very good. Thank you. Very much. Why is it wrong?
It's 5 instead of 4.
Very good.
It
Okay.
needs to be
Thank
two
you for
H.
noticing. Thank you for noticing. Now, is there any other mistake? Now, that
No.
is proof that you are thinking visually. If you think visually, you should be asking yourself, is this the correct drawing or not? If you draw for yourself and you don't spot the mistake, I mean, you get what I mean, right? It will be wrong, right? Like it or not, organic chem starts with drawing. Okay, so good for you. Very good, Nicholas. Right? Now, take a bit of a time and please confirm whether this is correct or not. Okay, I hope everybody's convinced that this is correct. Now, let's talk about the first reaction, plus bromine. Is there in the reaction map? And they will tell you, your reaction map does tell you that this will go into there, right? This will go into there. And by right, you should be thinking that this gets a BR, this gets another BR. If you do not understand that this is the result, you have some upgrading to do, definitely. This should have been in your notes. Now your BR is here. Go there. Okay, take one out. BR. Okay. If this doesn't exist in your note, or if you feel like you want to upgrade your note immediately, you should just draw. You probably should just draw this in a post-it note and just put it there. Okay. We haven't even finished reaction number 1 though, right? The keyword here is the same mass of product. Now, Sean, let me ask you, this and this, the result, are they the same molecule or not?
Yeah.
They are not, Sean and everybody else. They are not. Remember, the answer is visual. Look, the BR is at here and here. Here, the BR is at a little bit in the middle. Sean, can the first guy transform to the second guy, vice versa? Can or not?
No.
Cannot. Therefore, they are different. Therefore, they are isomers. Okay? Is this clear, sir?
Yeah.
Okay. Now, people, again, don't wait for me. If you want to upgrade your notes, you should put this in the post-it right now, right? Now, I'll continue talking about reaction 1. Now, since we know that they are, similar, they are not the same. And they are definitely isomers, right? Remember, isomers is different structure, but the same chemical formula. How do we know the same chemical formula? I mean, come on, right? There are 2 BRs, there are 4 Cs, the rest are H. The same chemical formula one. They're just different structure, right? Something that you can find only by drawing stuff, right? Different structure. So, will they produce the same mass? You learn from mole. The only thing that matters to mass is MR, You have to think about MR. If you forget the fact that you have to think about MR in mole chapter, here comes your revision. Now, let's ask Vera. Vera, first guy and second guy, do they have the same MR?
Yes.
Because same chemical formula. Does that make sense?
Yeah.
Therefore, they are not the same molecule, but will they produce the same mass?
Yes.
Okay. Everybody else, again, we're going very slow today. Thumbs up, please, if you understand or ask questions. The first reaction or the first statement is correct because of that. You have a lot of revision just now and a revision of OChem also. Okay. Put in your lecture notes, yeah? Upgrade your notes. Okay, first one is correct. I have to erase. I have to, right? I have to. But I will only erase a little bit, right? Only a little bit because I want to reuse the thing. Now, same thing, right?
Wait,
Same thing.
so
Yes. Yes,
can
ask.
you repeat the first one again?
Sorry, what do you mean, Anu?
Can you repeat the first statement again?
Why is the first statement correct? Is that what you're saying?
Yeah.
Okay, one more time, BR, is that okay? Correct?
Yeah.
BR, go. Oh, I'm so sorry. BR, go there, become, sorry, let me just get straight to the point. BR here and BR here, correct? BR
Yeah.
here and BR here. Now, they are isomers. They are isomers, so they are not exactly the same, correct? They are just isomers.
Yeah.
Yes or no? But
Yeah.
isomers means the same chemical formula because they contain all the same thing. What? The same chemical formula means the same MR. Why are we talking about MR? Because he keep asking about mass. He knows that the product is not the same. He knows that. But he want to test you. Not the same product, different structure, but do you think they'll give you the same mass? Yes, because the MR is the same. Am I making any sense? If not, clarify.
But why will the product be different?
Because look, one BR, let me put it this way. Look at the position of the BR. Look at it. Isn't it different? I'm explaining it visually. Isn't it different?
Yeah.
Therefore, they are different. They are called isomers because the same chemical formula, but different structure. First guy cannot be second guy no matter how you flip. Does that make any sense?
Yeah.
Now, if you get the first one correct, people, then suddenly you have a lot of head start for the second and third sentence. Now the reaction is no longer BR, but steam. What is steam? HOH, where will the steam go, right? Where will the steam go? It can go here and here. By the way, to make your life more troublesome, the OH could go here or the OH could go here. It could. The OH could go here. It's kind of random. So when reacting with water, this will definitely be your upgrade of notes. You end up getting two types of molecule. OH here, H here, or OH here, H here. If this is new, it should be upgrade your notes using your post-it. Okay. Now, this is only the first guy. What will happen to the second guy? What will happen to the second guy? The second guy, no BR. So the second guy is now, let me simplify, either OH is here or OH is here. You have two options, option number 1 and option number 2. Okay. Now, look at the situation, people. Are these the same molecules or not? Joel?
No.
Okay, no, Joel. I agree with Joel. If the OH is at the end or at this position or at this position, if I mention, for now they are different. Okay, yeah, I noticed a lot of wow. They really go all out with this. Wow, this question is crazy. Yeah, take it as a learning process. Yeah, the molecules are different, and I hope you can see it that way. So, sentence number 2 is definitely wrong already. Okay, let's continue to sentence number 3. Anything to clarify first? Now, hydrogen. You HH, you put in your H here, you put in your H here, right? Instead of having OH, and OH, this will end up being H and H, right? Okay, so Are these the same molecule? Yes or no? Sentence number 3, yeah? Kirana, are these the same or not?
Yeah.
They are the same. I mean, you're replacing it with all features, doesn't matter where it is. Okay, very interesting. How come this is correct, and this is wrong? Okay, we'll talk about it again later. But I hope from looking at it, you can see that, hey, they do produce the same molecule, isn't it? Right? Okay, last one. Combustion of 10 grams of each isomer will produce the same volume of gas. Now, when you write combustion, blah, 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 and same volume, do notice, I don't need drawing. No need drawing. Why? Back then in mole chapter, it's enough for you to write down C4H8. How do I know it's C4H8? Well, first of all, they tell me lah. Secondly, you can count if you want. They are both C4H8. So, they are both C4H8. Hey. Plus O2, plus O2. Reaction, CO2 plus H2O, CO2 plus H2O. You can go and balance, you probably want to from other questions, but the question only asks you if they have 10 grams, even though they are different molecule, will they end up, balancing differently, or will they end up being the exact same thing? Do you have to balance it to find out? Let's ask Nicholas. Do we have to balance it in order to find out they are the same or not?
Yes.
But look at it, Nicholas. Look, they are both C4H8, disregarding the drawing. The reaction C4H8, will it give you a different number here? Really? Logically, will it?
No.
No, right? Cannot be what? Why? Chemical formula the same.
Yeah.
Chemical formula the same. Reaction the same lah. In that sense. Therefore, since they are considered the same in the reaction, they will produce the same volume of gas. This is correct. I need a confirmation for the last one. Does this make any sense? Okay, I have some thumbs up. Okay, good. Okay.
I'm a bit confused.
Okay, one more time, Kirana, yeah. Let's agree that they are different molecules, can? They are different. Is that okay, Kirana? You must not
Yeah.
mute. Okay. But they have the same chemical formula, correct or not?
Yeah.
Therefore, will their reaction be the same?
Yes.
Therefore, if I each have 10 grams, but their reaction is the same, will I produce the same thing? Using your reason, will it actually produce the same thing, or will it be different?
Same thing.
Something like that. Does that make any sense?
Yeah.
The question is very, very complete in terms of knowledge, and therefore very, very annoying in exam. Very, very annoying.
Sure.
Yes, Nicholas?
Why is there a different way of finding out if the second option is wrong and the third option is correct?
No, I didn't use the different option. I'm just using drawing. I keep drawing.
No. You see, when you said both produce the same molecule reacted with steam, that was wrong. But then when you just change the steam to hydrogen, it's correct. Like, why do you have to use a different way of finding out if it's wrong
I
or
didn't use a different way. I just used the picture. So I put either OH here, option number 1, or OH here, option number 2. I did that, right?
Yeah.
I put OH here, option number 3, let's just call it that way. And this is OH, option number 4. And then I look at all my options. I have 4 options. Are they all the same? They are not. Do you understand?
Okay.
They are not all the same thing. Therefore, I cannot say sentence number 2 is correct.
Okay.
Does this make any sense?
Okay.
Right. There should be quite a lot of upgrading if you so wish. At this point, if you're confused how to upgrade, I really wish you will tell me and I will show you how. You need to develop your skill of upgrading your notes in a simple way. Please, let me repeat one more time. Please tell me if you are confused what to upgrade or don't know what to write or just don't know how to upgrade. Please tell me. All right. If there are no objections, can I move to the next question? The next question shouldn't be this long. Okay, no objections, yeah? Okay, let's get this straight. Back to Sean. Sean, will reaction map help here or not?
Yeah.
Very good. You are right, Sean. It'll take some time, but you should be able to find out who is right and who is wrong. So everybody look at your reaction map and I will call out one by one. Okay, Sean, let's start with you lah. Option number A. Which position is P? You know, top left, top right, bottom left, bottom right. Oh wow, this question is crazy. Wow. Wow, this question is okay, Sean, do you know where P is in the reaction map?
Bottom left.
Bottom left, correct? Is the alcohol lah. So P is here, option number 1, correct? Now, do you know where Q is? Do you know who the heck is Q, basically?
Bottom right.
And right here, Q. Now, to Sean and everybody else, I'm opening this up. Whoever can tell me that Q is wrong, tell me right now. Whoever can tell me that Q is a made-up thing, tell me right now the reason. I'm telling you that this guy does not exist. Who can tell us the reason why?
Is it because the closest thing it is to is combustion, which is H2O?
No. Again, my question is already hinting a lot, Joel. I am telling you that Q is wrong. Not option A is wrong. Q is wrong. Could you tell us why Q is wrong? This thing is wrong. Sorry, this thing is wrong.
Wait, is it because like it cannot be drawn out?
Okay, I'm going to try to draw it lah. Okay. When you see double O like this, please don't be confused. It's just your COOH lah. Right? So at least Matthew and Maris, you should know that. The question is, can I draw COOH? Well, can I? All right, see, I have drawn COOH. Again, the question remains. This guy is wrong. Why? Can you see it, Matthew?
Wait, give me some time to think.
Is it because, okay, Rachel say, is it because of carbon? Okay, you must explain, Rachel. You must explain why the carbon is wrong. You must. Rachel, you're on the right track, but okay, come on, people. Oh, come on, people. Nobody can see why this is wrong. Carbon dioxide cannot be
Because there's two oxygens, but only one H.
No, that's no. Rachel, your answer is also not true. This is not CO2 combined with H. No. They really don't mean that. I must admit they are confusing you guys. I must admit. This question is wow. Like this question is just a wow thing.
Is it
Sure.
'cause
Yes, Anu
carbon has
first.
4 hands?
Okay, Kirana first. Kirana.
Is it because carbon has 4 hands?
Very good. Anu, what were you trying to say?
I was gonna say the same thing.
Very good. Thank you, Kirana and Anu. Everybody should realize you need one more hand, ma. C is supposed to have 4 hands. So now, Kirana, do the honor. What is the correct thing, Link? How do we correct this, Link? Okay. What do we need here, Link? Kirana, you're muted. I lack one hand. So what do I do?
Put H.
Yep. People, this is the simplest upgrade you can offer yourself. I guarantee you this is very useful. This does not exist. You should write down a COOH does not exist. If you want to know why, just draw that. HCOOH exists. Upgrade this in your note. I guarantee you it's very useful one. Option A is wrong immediately because that option is wrong. I don't think it's a typo. I said already. Okay. Okay, remember, upgrade your notes. Now, let's turn to the next option. Nicholas, do us a favor. Option B. First guy, where is it?
CH3.
CH3CO2H, whatever that is. So where is that guy in the reaction map? Everybody, you see CO2 is CH3COOH, okay? COH, okay?
A fourth one.
Yeah, very good. COH is very clearly that's P lah. And then, so you have very little option, mass P plus what, right? So what do you think? Is there a reaction with sodium here? Yes, there is, right? Sodium is possible.
Okay.
Is the result correct, Nicholas? Help us. If you don't know, you don't know lah, but if you know, that would be nice.
I think it is.
Yes, it is correct. Now, for people, you may want to upgrade these notes. I noticed that some people don't realize this is the acidic part. This is the part where it can detach and become H+. So, CH3COO negative detaches with H+. That's the acidic part, the COOH. Nicholas, you know that already. It will, of course, react with sodium metal, and of course, the Na will attach itself here, of course. If you find this new, please upgrade. You will not regret it. So B is the correct answer. That's great. In exam, you're thankful and you will just move on. But this is learning, so let's talk about option C. Remember, upgrade your notes, yeah? I'll give you 30 seconds. Okay, part C, Vera, you will start whenever you're ready. Let's identify the position first. Vera, are you ready?
Yeah.
P.
Wait, I'm
right?
a little bit confused. Is it the
Mhm.
fourth circle?
No. This CH3, C3H7OH is an alcohol.
Oh,
How do I know? How do I know? The best way is just to draw. I draw 3 C's, right? Okay, 3 C's. And then I already have H7. See? 1, 2, 3, 4, 5, 6. Correct, Vera?
mhm.
So where's the last OH? Is like that. Is this a carboxylic acid? No, this is an alcohol. The position is bottom left. Vera, okay?
Okay, yeah.
Okay, good. Now, what is that KMNO4? Oh, no.
It's an oxidizing agent.
So this one, KMNO4. Oh my goodness. This question is crazy. Okay, so Vera, everything looks like it's checking out, right? Vera and everybody else. Everything looks like it's checking out. Is the result correct, Vera?
Yes.
And if that is true, then we have two options, which is a little bit weird. Correct, Vera? That is our first hint. The second hint is, I'll tell you straightforward, Vera, this guy is the wrong product. Even though the position and the reaction is correct. There's nothing wrong with the reaction. That guy, wow, this question's scary. They have a lot of traps. Vera, everybody else, can you figure out the trap for this guy? What is the problem with that guy? Everything seems to check out, it becomes wrong. What's going on here? Oh, crazy. I just...
One H disappears.
1H disappear is probably fine, Nicholas, but why? Because oxidation means you're adding in an oxygen, usually sometimes at the expense of hydrogen, if that makes some sense. That's probably okay. That's probably okay, right? Not the reason we're looking for, right? Good try. Somebody else, please venture an opinion. Make a guess. Why is that product wrong? Wow, crazy. Joel, any idea?
Not really, actually.
Okay, Joel and everybody, I'm going to draw. Okay. If any of you would have tried drawing, you may have...
Wait, I think I know.
Yes, Nicholas?
There's an extra C.
Very good. Excellent, Nicholas. Excellent. If you can figure this out without drawing, excellent imagination. Look, here's the extra C. Where will that come from? That doesn't make a lot of sense. The product is wrong. The product is supposed to be only 3C. So the last C converting to OH. This is called C2H5COOH for a total of 3 Cs. People, this is worth upgrading your notes. That one guaranteed. Worth upgrading your notes. Please do. If you do not know how to upgrade, just draw all this and say, oh, this guy is wrong, man. This guy is wrong. Extra C. This guy is supposedly the correct one. Just checking, Kirana, do you understand?
Yeah, kind of.
Very good. Matthew, do you understand?
Yes.
Sean, do you understand?
Yes.
Good. Nicholas, good job for spotting it. Okay. Upgrade your notes and ask. Okay. Well, Joel, let's start with D. Okay, D. Okay. Let's
Oh,
analyze why it is right or wrong. So where do we start with D? Where is P?
oh,
Where is CH3CO2H? It's just CH3COH. So where is it?
CH3COH.
Yeah, is in which position?
Uh, is it the bottom left?
No, bottom right.
Yeah,
COH. So it's P here, right? Okay, so far so good. Now, how about the second guy, Q? Does this guy exist? If it exists, where should it be?
oh,
That's crazy. Why this question is crazy? CH3OH. Joel, do you know where this guy is?
is it bottom left?
Very good, Rachel. Bottom left. Very good, Joel. Bottom left. Q. Now, Joel and everybody else, they are claiming that P and Q can react. Carboxylic acid and alcohol can react. Does this even exist in your notes, Joel?
Isn't it from alcohol when oxidation happens, then Like from Q after oxidation, then
It
P will.
becomes correct, right? Now, Joel is referring to Q oxidizing becomes P. However, this is not the reaction here, obviously, right? It's not the reaction here. It's the reaction on part C. Now, the question remains, therefore, Joel, is there any reaction between carboxylic acid and alcohol?
No.
The answer is yes, Joel. It is in the polymer section. Carboxylic acid and alcohols do react. Now, this is not supposed to be an upgrade. You're supposed to see this in your notes. So I'm going to put this one more time. The reaction is valid. Something else is wrong. Something else is wrong. Crazy. So far, this question has been very crazy. Now, CH3, COOH. Look at your polymer section. I face the alcohol with the carboxylic acid, and then we do something like that all the time, and then this ejects into H2O, and this becomes your ester bond. You gotta confirm that this is not something new. This is not supposed to be something new. There you go, your ester bond here. Ester bond created by eliminating this, and therefore holding this and this hand. This is your ester bond. Okay. The best way to explain ester bond is to simply draw it out. Now, somebody please offer an explanation why this guy is. Uh-oh. Uh-oh, can we say that this guy is wrong? I'm sorry. Can we say that? Uh-oh. Oh dear. Stop. Okay. Time is up. No, time is up. I said break time is now in. Nicholas, follow the answer until the end later. Okay, we're gonna take a break first. For the rest, please think about option D, whether it's right or wrong, or whether there's a mistake in it. Okay, let's take a 5-minute break.
Okay, bye.
Bye-bye.
Chair,
Yes, Anu.
where is the reaction for B?
Where is the reaction? You mean in the reaction map, is it?
Yeah.
There is a very similar reaction. So let me find out for option B, yeah? I'm sorry, let me use it. For option B. Again, reaction map. And the P will be here. Please agree with that.
Yeah.
In your reaction map, we will probably see an OH instead, right? Which is to say, this is an acid and alkali reaction. Will that be okay?
Yeah.
Now, in this option B, we are saying that, hey, it's a base, acid and base reaction. We are referring to your Sec3 acid and base reaction. The question is, again, will a sodium metal react with acid? Yes or no?
Yeah.
It will. Does this make any sense?
Yeah.
If you consider this to be not in your reaction map, time to upgrade it, then it's something worth putting in, if that makes some sense.
Okay.
Okay, please do. All right, let's do my check. Rachel, are you in? Just following the chat. Okay, good. Anu, Joel, are you in?
Yes.
Okay, good. Joel is in. Okay, Kirana, Matthew.
Yeah.
Okay, cool.
Yes.
Okay, so Ern and Vera.
Mm-hmm.
Okay. Okay, good. All right. Now, people, I've used the break time to confirm one thing. Remember, I always told you I never really look at the answer key one. All my answers come from knowledge or principle. I don't teach from answer key. So sometimes I will encounter questions that feel, hey, how come, for example, in this question, there are two answers. Okay. So now first, I will explain why I think B and D is correct and therefore what to do about it. Okay. What to do about it. Okay. Now, for option D, if I look at it very carefully from many sides, I cannot find the mistake. So let me just repeat this one more time to be very clear. Here is your CH3COOH. There you go. Here is your alcohol, and they do react ester bond, polymerization. And then the ester bond, the ester that results look like this. And this, if you see, will be your CH3. There's your CH3. There's your CO2, there your COO, right, with the ester bond. And then finally your CH3 also. By drawing, nothing seems to be wrong, and I can confirm this is the supposed correct answer. Right, so to me, B is correct, D is correct. I've used the time in the break to confirm that B is correct. B can happen and B should happen. Right, now the answer key chooses one, right? The answer key chooses
Wait, I think B is wrong because like it says compound P and compound Q, but Na is an element.
Oh yeah, you're right, isn't it? It's a compound. Excellent, Matthew. Thank you very much. B is wrong because Na is an element. Wonderful. Okay, that settles it. D is correct. Any questions? If you need time to upgrade your notes, please tell me. These are all very valuable stuff. Troublesome questions are very valuable for upgrading notes. Okay, no more time needed. All right, so now, after you've done such a troublesome question, 36 and 35, 37 will look quite easy. Will look quite easy. Okay, go ahead, people. Question 37. They always make it troublesome. Okay, Kirana, this tartaric acid should feel something new or also feel something familiar. Where's the position of tartaric acid in the reaction map?
Is it bottom right?
Bottom right. Because of what? Tell us. Visually, you can see the reason.
COOH.
Wonderful. There are two, and that's okay, right? So this is your tartaric acid. I challenge you, Anu, is there another possible position? Is there another possible position for tartaric acid?
Can it be bottom left also?
Yes, because alcohol. For some reason, tartaric acid contains alcohol, so it's here, right? Now, to be fair, the question clearly wants to talk about salt, acid, and alkali. The question really wants to emphasize the acidic aspect, not the alcohol aspect. Why is it important to notice that the alcohol can be here, a TA can be here? Because the question can easily change. The question can easily change into making use of the OH. Okay, just want to say that. Okay, although the question is super clear about him wanting it to be acidic, salt, and alkali. That's also fair. So Kirana, good job for the first observation, but also please take note, alcohol is possible. So now this should be hopefully easy to do lah. This is acid, base, and salt. If anybody has an answer or some questions, that would be nice. Please, I remind you, if you're confused, please draw stuff. Drawing is the best thing. Okay? Drawing is the best thing. Please try drawing things. Matthew, do you have an answer?
I was writing down stuff. I haven't looked
Oh,
at the
go
question
ahead. Go ahead. Joel, any answer so far?
I'm still drawing out.
Oh, please do. Please do. Drawing is good. Sean, maybe some possible answers?
Okay, I'm still thinking about it.
Please, but please try to draw, yeah? All the drawing is there already, so you do something, right? Vera, any possible answers?
Is it one?
Mm.
Sorry. I didn't see the A, B, C, and D.
So what you're saying is that this is correct, the rest is wrong. Is that what you're saying?
Oh no, I haven't looked up to 4.
Right. So you check it out one more time. Anybody would like to volunteer an answer?
Sure, I've only done 1 and 2, and I think 1 and 2 are both correct.
So you're saying that this is correct, this is wrong.
No, I haven't done 3 and 4 yet.
Right. Okay.
Yeah.
So far, I agree with Anu, but hopefully we can see the reason why. Wow, this school is crazy, man. What school is it? Choa Chu Kang. Analyzing the question takes too much time. Kirana, any possible answers from you?
I'm still thinking also.
No, please do. I'll give you guys 1 more minute, okay? Okay, let's start. So people, the reaction we're concerned about is here. Just to confirm, this is the acid and the alkali reaction. Okay, in your notes, it will be NaOH. Please don't be bothered by the fact that change it to KOH. You should be able to handle this. KOH is K plus and OH minus. This OH will react with the H here, right? They will react, they become H2O. And the K will take the place, so to speak. So this K will go here lah, and replace this as K, something K. Okay, now with that, I hope it's very obvious. The C4 is always correct. This H5 comes from, I don't know, 1, 2, 3, 4, 5, 1K lah, 1K here. So this is correct. And if I replaces 2K, the O is still 6, the H reduces by 1, so this is also okay. So one more time, it's a matter of replacing 1K or replacing 2Ks. So far, option 1 and 2 is possible. Option 3 and 4 is not, because there is no way you can replace this with K. They are alcohols, not carboxylic acid. In the reaction map, there is no such thing as alcohol plus alkali. It is true that it never happens. So this doesn't exist. Don't be fooled. Hopefully that is clear. So 1 and 2. Okay. Now option 1 is possible if the KOH is very little. So the KOH is lacking. Option 2 is when the coases is in excess. One more time, if you have too few KOH, maybe only 1 is being replaced. If you have excess, then of course 2, right?
Sure, can you repeat why 3 and 4 cannot?
One more time. 3 and 4 means we're looking for things other than these two already, correct? But who else can react with potassium hydroxide? According to the reaction map, there is only one reaction between, somebody with alkali. Only one, right? Correct or not, Anu?
Yeah.
This guy is alcohol. Don't be fooled. They're testing you. I think they're testing you whether you know this is alcohol or not. It should be quite obvious. Can alcohol react with alkali?
No.
And the reaction map is reliable. So don't be fooled lah. 3 and 4 is wrong. There is no other way to do this.
Okay.
Okay. Everybody else, if it doesn't make sense, please I'll give you around 30 seconds to upgrade your notes. Please note that your reaction map has been very instrumental in explaining to you what's going on, what can, what cannot. That will remain true no matter how easy or difficult the question is. Therefore, upgrading the reaction map is a very good idea. The complexities will come from that, okay? That and the polymer. If there's no objection, we will move to the next part. Now we are at polymers, and polymers, they like a lot. Look, monomers, polymer, 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 and well, this one isomer, right? So 2 polymer questions. They like it a lot. It's either the reaction map or the polymers, right? Joel, help us confirm a few things first. Okay. Are these 2 familiar to you?
Yes.
And are they the ones usually participating in, polymerization?
Yes.
Good. Right. Let's confirm this one also. Are these 2 usually the ones participating in polymerization?
Yeah.
Good. Are these 2 usually blah, blah, blah?
OH and NH2, yes.
NH2, yes, right? OH, okay, good. And OH, therefore also yes, because OH is yes, right? Now, the candidates are normal people, and the guy in the middle, Joel, just help us confirm, does it matter or not?
No.
Doesn't matter too much. It's there. The holding hands left and right is what matter. Remember, polymerization is I hold left, I hold right. Okay, Rich. Okay. Now, how many of these monomers above will react with this guy? Oh, wow. There's some new guy here to form a polymer. I guess that is the question. Okay. Let's go. Look at your polymerization note, right? And then hopefully that will help you. Now, I'm writing something that is supposed to be your notes, okay? Your polymerization note should have something like this. This guy react with OH, right? This guy reacts with the amine. Also a reaction like that. Okay, it reacts like that. And then this forms amide bond. Oh, heaven. Amide bond. And this one for, I draw it wrong here. Oh yeah, I draw it. Eben, I can see you. Can you hear me?
Yeah, sorry.
No problem, Eben. Are you tired? CCA ma?
Yeah, a bit.
Okay. Just try your best. If it's too tiring, what to do, just look at the recording later, right? Now, for your benefit, Eben, today we are actually taking it very slow and very detailed. We are trying not to introduce anything new conceptually, and we didn't. We only have a lot of details. The reason is because I want people to upgrade their notes. There have been a lot of things that we can upgrade just now. You can follow it using the recording, but therefore you didn't miss anything. You can just look at the recording and see what happened. There is no major new things. It's a revision of all the things. Okay, Evan? Now,
Okay.
if you're too tired, just go and rest, I understand. But don't forget to catch up later. Right. Okay. Now, your polymerization note should contain these two major things, right? And then one more when they use the double bond one, right? When you use the double bond one. But the double bond one is not needed here. No explanation for now. Just trying to focus you on these two things. Okay, that's enough help. Let's try. Sean. Okay. The below guy should be your concentration. Now, do you see anybody from the below molecule? Anybody that is from this reaction? Is there anybody from these two reactions?
Yeah.
And what is it?
There's ester bond.
You mean in the blue one, there's an ester bond? Really?
Eh?
The ester bond happens after you polymerize. When you hence you polymerize. So by right, the raw material does not have an ester bond. Ester bond is the result of the polymerization. I hope that makes some sense. Now, therefore, Sean and everybody else, for the raw material, the monomer, you're looking for this guy, correct? You're looking for that guy, and you're looking for this guy also. Does this guys exist in, well, this guy? Yes or no, Sean?
Yes.
And what exists? Who exists? What captures your attention?
There's there's COOH and OH.
Over here, Ken? Anything
And
else?
on top also have.
Very good. There are two. Okay. Now this opens up, well, two possibilities. Let me ask Sean for the benefit of everybody. Sean, having two COH, is it important or not for polymerization, or is it just a bonus?
What does that mean?
One more time. If this is not COH, if this is something else, okay, whatever it is, it's something else. I only have one COH here. Is that good for polymerization or not good?
Good.
The answer is it depends.
Oh.
If this guy is OH, then look, there is an OH here. It's possible to ester bond. Or if this guy is NH2, good, there's a possibility of amide bond. If this guy is only H, then not good at all. There is no possibility of polymerization. You cannot polymerize with only left hand. You must polymerize with your left and your right hand, if that makes some sense.
Yes.
So Sean and everybody else, having a carboxylic acid here is very good, but there are other options that. It's just that the options must be between these three. Now, back to you, Sean. All right. So let's try molecule number A, B, sorry, molecule number 1, number 2, number 3, number 4. Will molecule number 1 help molecule number 5? Let's call this molecule number 5, okay? Will molecule number 1 help molecule number 5 basically hold hands infinitely? Help or not?
Yes.
Very good. For those who are not certain, it is because of amide bond. Look, carboxylic and H2 here. So I put NH here. I can form amide bond. I can form another amide bond and H2 here, and the cycle of holding hand will not be broken. Good job. So option number 2, will that help or not?
Yes.
Because?
Because got NH2 and you can form amide bond.
Okay, now here's the answer. Now I'm gonna draw it. Wow, this question, wow, this school crazy. Crazy. They give you a lot of traps. So yes, Sean is correct. This will form your amide bond. Okay, we have fulfilled the criteria. Amide bond. The problem is now we only have COOH here. That's the problem, right? Here also you can put your NH2 here, which you form your amide bond. But the problem is you have COOH here, and who can COOH react with? In that sense. This N is the problem. This N is the problem. It cannot continue holding hands. It can at most hold hand twice. This needs to make some sense. If it doesn't make sense, please tell me, Sean.
It makes sense.
Okay, everybody else, let's pause for a while. I'm telling you, left and right work, and then it will stop. That's not a polymer. Does this make any sense? Maybe a thumbs up will be quite good, if you understand. Okay, I see some thumbs up. I'm quite happy. Okay, good. Definitely materials for your notes, right? Definitely. Okay, we'll take it slow. We'll take it slow. Okay, you have to think one step ahead, right? Okay, you have to think one step ahead. So 2 is problematic because this is great and this is great, but this is not so good. Kind of terminates. Okay, now maybe let's ask Anu. Anu, how about option number 3? This is molecule 5.
Can.
Can. So I'll put 3 here, correct? And 3 will face NH, right? Correct or not?
Yeah.
Okay. Why can I continue? Let me confirm. Because if I put a molecule 5 here, will it react?
Yeah.
Yes, ester bond. Okay, good. Then the same thing will happen. I put a 3 here and I can react with a 5 here. If everybody can see this, good for you. These two things works very well. Amide bond, ester bond, amide bond, ester bond. Such a complicated. Anu, do us the honor of completing. How about option number 4? Will it work?
Yeah.
Okay, again, why? Because if I put molecule 4 here, I get my OH here. Does it work? Yes, ester bond, right? I have another OH here. Will it work with molecule number 5?
Yeah.
Yes, ester bond again. So this one works and this one works. And you have the answer as C. People take some time and upgrade your notes if you find this to be something new. Okay, if you want to clarify. Okay, I'll just go straight to Eben. Eben, can you follow?
I think still can follow.
All right. Okay, good for you. Rachel, just to confirm, are you back and can you follow? Okay. For those who are happy with upgrading of their notes, okay, please just thumbs up and then I will continue the 30.
Wait, just to confirm,
Yes.
polymerization is holding hands infinitely, is it?
Infinitely is a method of speaking. It's more like around 50 to 100 holding hands. It's long enough.
Okay.
Okay, not infinitely, but you cannot stop at 3.
Yeah.
Yeah, something like that. Yeah, 3
Okay,
doesn't work.
okay.
Right.
Understand. Okay.
Good question. For those who are happy with the upgrading of your notes, please give me some thumbs up. I'll show you 39 for those who are ready. Good, 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 Rachel. Good, Rachel. Good, Veron. Kirana and Saan, let me confirm. You still need some time. Oh, Kirana. Okay, good. Hopefully that will help improve your notes. Now let's focus on 39, a simple question. For those who don't remember what's empirical formula, it is a secondary topic they're applying it to. Okay. They're just saying, let's say there is C2H6, you simplify. Empirical formula is simplifying to CH3. Okay. This is the real thing. And this is the simplified thing. Why do we even bother with a simplified thing? There's a reason they don't tell you, but empirical formula is simplified formula. It is not real. It is just simplified. Hopefully that should help. What do I have? Okay, Kirana. Now let's start with you. Yeah, Kirana, please help us remember what is the meaning of this N.
Is it something got to do with the amide bond?
The amide bond, not really. This N simply means you are repeating yourself in the sense that this will have another CCHH, the exact same thing.
Oh, okay.
CCHH, and then another CCHH, because remember, polymer is, in a matter of speaking, infinite. Let's not draw too many things. Let's just, bracket N to indicate the repetition. I hope this is clear. Okay, Kirana?
Yeah.
Okay, good. Now, since it is a repetition, then you can simplify, right? You can simplify. Now, Kirana, let's kick things off. How many C do you see here?
2,
And how many H?
4.
And everything is with an N, right? We don't know
Yeah.
how long. Can this simplify to CH2?
Yeah.
Yes, and A is definitely correct. So, it's not, so A is not the answer. Let's do B one more time. How many C?
4.
And how many H?
8.
8. And with an N, simplify, does it become CH2?
Yeah.
Of course. So B is also correct. A is not the answer. Okay, who else? Okay, Matthew, let's try D first. D, help us. Here.
C3,
How many H?
H6.
With an N, so does it simplify to CH2?
Yes.
Yes, so far so good. Now let's confirm that option C is wrong. So this weird guy, just count, right? There's nothing wrong with them introducing you a weird one. So how many C? Matthew also, yeah? Matthew, how many C?
Oh, my bad. 8.
And how many H?
8.
8 with an N. Now, obviously, this will be just CH, and this is wrong. Right? I hope everybody is quite clear. Comparing to other questions, this is Very easy lah. If there is no question, one. Isomer question. More question. If you do not know methyl propanoate is, they give you the molecular formula, which is very helpful. Very helpful. They, however, do not give you the drawing. They don't give you a drawing. And you do not know what is methyl propanoate. It's a very weird thing, but they give you one more hint. It is an ester. Okay, it is an ester. Just to emphasize, ester is a combination between two things, a reaction between two things. Anu, please help us. Ester is a result of reaction between who and who?
It's between COOH and OH.
OH, right? Which is to say the reaction between alcohol and, you know this from polymerization, but of course it can be a normal reaction also, right? And then ejects, and then you will need to have an ester bond. Keep repeating this, correct, Anu? Ester bond.
Yeah.
So an ester must have an ester bond, which looks like this lah. I hope that makes a lot of sense. There is an ester bond. Anu, do you have an answer for us?
No.
Okay, ester bond. Anu, let's check out option C. Who is this guy?
Alcohol.
Come on.
Sorry. COOH.
Which is carboxylic acid.
Yeah.
Now, is carboxylic acid an ester?
Yeah.
No, carboxylic is not an ester. The carboxylic acid, together with alcohol, produces ester. The carboxylic acid changes in order to become ester with the help of another alcohol. Make sense? Carboxylic acid is not an ester. And furthermore, do you see any ester bond in option Z?
No.
No. Now, this is not an ester bond because this guy has to be something else, right? So this is a carboxylic acid, not an ester, and therefore C is wrong. Right. Oops. What happened? Okay. Vera, option D. Who is this guy? Who is this guy? Oh, wait. Option C is possible. No, option C is possible.
Wait, I'm a little bit confused. Because isn't isomer like the same chemical formula?
No, you're right. An isomer has the same chemical formula. No, you're right. But the structure can be different. Now, this is something I haven't mentioned to everybody. Structure different means family can also be different. So when I mentioned to Anu just now, this is a carboxylic acid, which is not an ester. That is correct. It is not an ester, but it doesn't stop it from being an isomer. It doesn't. It still qualifies if the chemical formula is the same. So, Vera, I'll go back to Anu first. Yeah? Anu, let's count the chemical formula one more time. What is the chemical formula here?
C3.
C4.
H8.
And O?
O2.
Okay. To you, Anu, even though it is not ester, even though it's carboxylic acid, hey, different structure. We know that, right? different structure, but same chemical formula. Option C is definitely a possible answer. Make sense?
Yeah.
Okay, now let's get back to Vera. Vera, back to you, option D. Is option D a possible answer or not?
I don't think so,
Because?
because there's only 3 C's.
Correct. GC, blah, 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 blah. Okay, that's it, gone. Good. Now, do us a favor. Let's analyze option A. Is it possible?
No.
Because C3, blah, 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 that's it already, correct?
Yeah.
Option B. Let's try.
There's only one O.
Very good. C4, H8, nice. But O only one. Also gone, that's it. Comparing to the other questions, these questions are quite easy. Now, the only new thing you may want to add, people, is this one. Okay, structure different can actually mean the family is different. In this case, one is carboxylic, the other one is ester. They're actually very different chemically, but hey, same chemical formula, it's okay, it's an isomer. Okay, another 10 seconds if you want to upgrade. My explanation was, yeah, could have just answered this. Okay, now people, let's revise. We look at question 34, which is reaction map substitution. Question 35, suddenly we cover a lot of more, suddenly, with the reaction map also. Okay, very troublesome question. Question 36, we end up talking a lot about the reaction map also. And good job, Matthew, for spotting that this is not a compound, right? So good, that settles the problem. 37, we end up talking about the reaction map is only slightly not so complicated. 38, polymer, 39, polymer, and 40 is the isomer. Now, what I'm trying to say is the MCQ is so greedy in that sense. The MCQ covers so many topics. It basically covers all the major topics. I am, in this last 15 minutes, trying to show you that the way they ask question in paper 2 is going to be the same. One more time, One more time. I am betting in paper 2, which I've never seen, they will talk about reaction map, always like that one. They will talk about mole, always like that one. They will talk about, well, reaction map again. They will talk about reaction map again, right? They will talk about polymer. They will talk about empirical formula, maybe not, but still polymer. And they will talk about isomer or isomer, maybe not. Let's see. Let's see. But this is basically what they will do in paper 2, I am betting, right? Let's check it out. No. 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 Okay, right. Okay. Joel, how do we know that this is an organic chemistry question?
Or the structure.
The structure, the drawing, the CN.
Polymer.
Yeah, very easy polymerization. Obvious, yeah, it's obvious. Good. Now, it turns out that they really like polymerization question. If they already asked twice, they still want to ask again one. They always ask polymerization question in paper 2. If you are good at it, it's a very good thing. Okay, hopefully you will be very good at it, right? You don't know what is styrene, who cares? They give you the drawing, that's the important thing. Now, Eben, please help us. What is this X? How come there is an X here? What does this X mean, Eben? Any idea? X is a symbol for something. Maybe your teacher haven't mentioned. No idea, Eben?
X. Is it an element?
No, surprisingly there's no element called X, but it symbolizes a certain group. Which group? Any idea? Okay, this symbolizes the group 7,
Oh.
which is, it can be Cl, it can be Br, it can be, actually the iodine doesn't work here lah. So there's only 2 options here, is Cl and Br, but group 7, the halogens. Okay, this is a formal representation, so you guys should know X is usually like that. They will not use X for other things usually. Now, why am I explaining to you? Because they never explain what is X. So X is a question mark. But I'm telling you, unless they re-explain themselves, unless they wish to override the formal understanding, X is group 7, which in our case is either Cl or Br. It can be F from time to time. These are group 7. If they never say, this is the interpretation. Now, for butadiene, butadiene is not something very complicated here. However, can anybody point out what is the weird thing with this guy? Can anybody point out? This is weird. Does anybody know why it is weird?
Because one of the C is missing a head.
You mean buta means to have 4 C, is it?
C2H3, you draw it out.
If you draw it out, yeah, if you draw it out. So let's draw it out, okay? Let's draw it out, which is very important, right? H. I guess I draw it here and I draw it here. Now, shouldn't there be more than 3 H's, correct? Okay, so is this wrong? I can tell you, no, it's not wrong. Who can solve this mystery? He is correct. C2H3 is correct. Who can solve this mystery?
Is it double bond?
Very good, Joel. Double bond. Where?
Between the C's.
Which C's? There are 4 C's here.
The last 2 C's.
Very good. Because there's no other option. He already said that this is double bond, and he already said that this is a single bond. So there's no other option. Make sense? Only that. Anu, were you trying to say the same thing?
No, not much.
Okay. Then, Joel, do us the honor of recounting. If you put another double bond here, how many H need to disappear? Okay, Joel.
Is it 2?
1 from here, then 4 hands, right?
Yeah, and then one
One
more.
from here, also 2 hands, and you nice have 3 H's. Does this make some sense now, Joel?
Yes.
Okay. Furthermore, people, there is a clue. This is diene. I have never taught you this before. This is detail. Let me split this for you. In the name, there is a clue. Buta. I'm gonna split it like diene. This di means 2, right? 2 as in double, or there's 2. So double in, and double in, of course, means there is 2 double bond. In the name, there is already a clue. It's butadiene instead of the normal butene. If it is the normal butene, then there is only 1 double bond. The diene indicates there is 2. Okay, this is worth some part of your notes, but your teacher will also teach you, so I wouldn't worry too much. Okay, I help you analyze what they're giving you. It's a combination of something old and something slightly new. Okay, now hopefully you have drawn that, because I have to erase all this. Okay, referring to your polymerization note, there are only 3 reactions you need to consider. When it is polymerization, it's very nice, people. It's only 3 reactions. It's not the complicated reaction map. Okay, it is either the carboxylic acid with alcohol or the carboxylic acid with the amine, or for some strange reason, the C double bonds. This can also polymerize, right? This is called the esterification. This is called the amidification, and this is called the addition. You know, this is too obvious already. Matthew, do us a favor. What type of polymerization?
Addition.
Because there is no alcohol, there's no carboxylic, and there's no amine, correct?
Yeah.
Explain your reasoning. Right now, you don't have the words, Matthew, but I mean, you will be able to explain because your teacher will give you the wording. Will that be enough for now?
Yeah.
Okay. Now, whew. Everybody else, Matthew, just give us the honor of explaining. Structural formula means what?
Like you just draw the structure.
Very good. For 2 marks, it's not bad. People, please draw. If you want to ask, please ask lah. Right? This is a very easy starting format. So, if you want 1 minute to draw, okay. Now, let's start. We are concerned with the addition polymerization. Let me repeat for you. The addition polymerization, you have to break one, and then open up. So you have a dangling hand here and a dangling hand here by breaking one of the double bond. Break the double bond, just one of them, and then dangling hand here, dangling hand here. This is a much simpler reaction compared to the, alcohol and whatever not. So it's nice. That's addition polymerization. Now, therefore, what you should be drawing is like that. You should be joining this hand, and then you should be doing the never mind. I'll just make it complete. You should be drawing this. There is no double bond here, only single bond. Let me repeat. There is no double bond here, only single bond. Connect them, dangle, dangle, bracket, and end. If you are right, please do a thumbs up. If you're wrong, do not be shy. Please clarify. And I see either a thumbs up or the clarification.
Wait, for the butadiene, right?
Yeah.
Do you like keep the same structure as the one given the question, or do you like draw out all the C's?
Right. Okay. So Matthew's question is very valid because he's worried this guy may mess it up. Correct, Matthew?
Yeah.
Okay, let me draw for you. I'm only drawing the C. The double bond is here and the double bond is here. So far, so good, Matthew. Do unmute, Matthew.
Yeah.
do you notice that they are super symmetrical? The butadiene is symmetrical.
Mm-hmm.
Only because of that, you don't have to worry. Because
okay.
when it happens here or whether it happens here, the result will be the same lah, if that makes some sense.
I see. So you only like break one double bond.
Just one. There is a reason why breaking two that. Ooh, you know what? If you want to know the answer to, can I break two? Either year 6 or year JC2 or university. Right now, you pretend that if it's symmetrical, just break one. Simple life. Good
Okay.
question. Good question. One more time. It is because it is symmetrical, we ignore the complication. I think they intend to make it symmetrical. So it doesn't matter which one you break. The other, you pretend it doesn't break. Actually, it does break, and that is the end. We do not have to talk about it. It is a very good observation from Matthew. Anybody else want to clarify? Now, do note, people, the X, whether you know it's F or CL or BL or not, shouldn't affect your first 4 marks. This is quite an easy 4 marks. And that is what you expect. The first few marks are very easy. You should be able to do it. Okay, now here comes the first challenge. The first challenge is in option number 2, only for 1 mark. Please read, and I'm gonna ask somebody to attempt. Evan, do you have a guess for B part 2?
Yeah, but just a guess.
Go ahead. A guess is important. Go ahead.
I guess
Evan, you're yeah, okay, yeah. Go ahead.
Can I say that polymerization is a random process?
Unless you try to make it regular, yes, it is random. What is your point? Tell me. It's a very interesting point.
It will not like. I guess it wouldn't be perfect. I mean, like it wouldn't be perfectly alternating.
Meaning, be more clear. Be more clear. You seem to be aiming at the right thing. Go ahead. Perfectly alternating, not styrene, butadiene, styrene, butadiene. So let's say styrene, then what? Not butadiene? Then what should this guy be if it is not a butadiene? That is what I'm looking for. If it is not butadiene, what could it be?
I don't know.
Then, Eben, let me give you a hint. Wait. Don't go. Let me give you a hint. Let me give everybody a hint. Let's pretend there is no butadiene. Let's pretend there is only styrene. So far, so good, Eben?
Yeah.
Can styrene only polymerize?
Only.
There is no butadiene, only styrene. Can polymerize or not? Can hold hand left and right infinitely? Can or not?
No.
Can.
Oh.
Styrene will hold hand with styrene lah. Understand?
Okay.
So styrene will hold hand with styrene without butadiene. Let's flip. If only butadiene, no styrene, can it hold hand left and right infinitely?
Can also.
Can also. Correct. Because addition polymerization is that simple. The other one, the ester and amide, is the more specific one. So back to the question. If it is not styrene and butadiene, then styrene will hold hand with
Itself.
styrene,
Mm.
and then maybe randomly butadiene.
Yeah.
And then maybe styrene again, and then maybe butadiene, and then butadiene. So it's not a very regular arrangement. Do you understand, Eben?
Okay.
This is the reasoning, even though for 1 marks, and you may not be able to write down nicely, but please understand the reason first. Okay? If you want the formalities, is because styrene can polymerize with styrene. You can just say that one. Styrene can additionally polymerize with styrene and with butadiene. Therefore, the arrangement can be SSB or SBSB or blah, 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 something like that. It's just an additional. Okay. If you consider this to be new, please upgrade your notes. Okay. Addition polymerization is just more forgiving. Okay, and we run out of time. Let me check. Okay, for the last two, I just want to show you that the type of question they ask is already predictable. Okay. Part C. Anu, please tell us, is this reaction map or not?
No.
It is. Oh, goodness me. Okay, it is. Yeah. Okay, which position? What is the position of butane in the reaction map? Nice.
Is the top
Yeah.
right.
Good. Butane, and the arrow is here to butene lah. So what is the reaction? The reaction in your note should be cracking. Correct, Anu?
Oh yeah.
Yeah. So people, they don't ask cracking a lot, but when they ask, please notice it's there already. Okay, you will be able to use your reaction note to answer this one. And then this one is something your teacher will give you. My point is the reaction map is there again. Now, the last one. Who will do the honor? Sean, last one. What kind of chapter is this? Chem is combining with what chapter here? Sean?
Moles.
Moles, but a very specific mole called, there are 3 specific moles, empirical formula, which is not here. Empirical formula, excess limiting, which is not here. This one is the yield. Hey, they are doing the same thing again. People, they're just combining with the same thing that you can predict. That's all I'm trying to say. Can you do this? Maybe yes, maybe no. We'll do it next time. If you can, it must be because your mole concept is strong. It must be because of that. Okay, let's do it later. If there is no other question, I hope you have had a good experience of upgrading your notes today. Let's make it a standard thing next time. Any question to clarify? Very good. If not, for those watching the recording, please catch up with us. I'll see you guys by Wednesday. Bye.
Thank you.
Thank you, Joel.
Thank you.
Okay, Kirana.
Thank you.
All right,
Thank
Anu.
you.
All right, Vera.
Thank you.
All right, Evan.
Bye-bye.